So this is the project which we are currently undergoing with the help of second year engineering students. Some of the first year students are also there, along with industry professionals and some research scholars. So the topic is detection of ADHD by EEG signal and machine learning. So what is this ADHD? ADHD is a neurodevelopment disease related to our brain. So the full form is attention deficit and hyperactivity disorder. So, what are the symptoms? The symptoms are inattention, hyperactivity, or impulsivity. So, most of the time, we see some of the kids who are constantly running. They are in the state of hyperactivity. We think that the student or the child is very much, in Hindi we say mastikhor, but actually he might be undergoing this ADHD kind of disease, you can say, which is curable if it is detected at a very early age. Okay. So, how do we detect this ADHD by EEG signal and machine learning that we are going to see right now? So, currently you can see a child in this photo, and there are large number of electrodes, or you can say sensors, and these sensors are numbered. So, these electrodes or sensors are put or glued on the head of a kid. It is not at all harmful, and the EEG signals are recorded. What happens is, in our brain continuously some or the other activity is going on with our neurons or with our cell. So that activity is captured in form of signals. The way our heart generates signals, you might have seen ECG signals. Similarly, brain also develops a kind of signal which is termed as EEG signal. Brain has got many sections. So for different section, we are having different electrodes over here. If you look it carefully, you can see the shades of the colors of the different electrodes. Okay. So these are the different regions in our brain. So this yellow color is the frontal region. Then we are having the frontal central region. Then we are having temporal region, which is in green color. Then there is occipito-parietal region. Okay, and this is how the electrodes are distributed on the head. So when you see from the top of that child, you will see somewhat like this. Okay, and these are the EEG signals. These are the EEG signal. For example, this FP1. If you zoom it, you will find FP1. So this is that electrode FP1 where my cursor is currently. So this FP1 electrode gives out this signal which is enclosed in this box. Similarly, all these electrodes will generate a kind of signal that you can see over here. So you can say that these are healthy signal for the person who is not having any kind of neurological condition. But what if a person is having some kind of neurological condition, whether it is anxiety or say epilepsy or ADHD, the signal will change. This is how the signal will drastically change, as you can see. Okay, so this change in the signal, it gives us the information that there is something wrong with the brain, and it becomes very difficult for the doctor currently to identify that if the signal is happening like this, then what the patient might be having. So detection of this kind of disease by current doctors and in the medicine fraternity is a very challenging task. Hence, what we are trying to do is, with the help of this EEG signal, we are trying to detect whether the person is having ADHD or not. For example, we are trying to develop a system wherein someone will just put his EEG signal. And just by putting the EEG signal, the system will give an output whether the person is having ADHD or not. As simple as that. This project is not that easy as it looks, but we are working on it in a very bits and pieces manner. Okay. So this is the first signal given by FP1 electrode. And if I just plot this first signal over here, you can see it. I've just elaborated this first signal over here, FP1 signal. Okay, every electrode will give its own signal. For example, this signal which is C3, C4, they are of central region. This F3, F4, they are of frontal region. Okay. And let us just get some more information about signals first, then we'll move forward. Okay. Now, when I say that I have acquired a signal from a person, listen to me carefully when I say that I have acquired a signal from a person. Actually, what I have acquired is I have acquired such data points. Let me see if I can zoom. Yes, I can zoom it. I have acquired, when I say I have acquired a signal, I say I have acquired these data points. These data points. You can see small circles are there. These data points we acquire from the machine. After acquiring this data point, what happens is the software will just join all the data points. And after joining the data point, it will appear like it is a signal. Actually, what is it? These are small dots. You can say this is the zero position from zero position. Now, this is a dot. from zero position. This is the topmost dot, you can say. Okay. Similarly, at the same point when it is converted into a signal, or when we join all the dots, this is that point. So how do we receive a signal from a patient? So whenever a signal is recorded by that EEG electrode, we can acquire the signal in this Excel sheet in the form of these data points. So this 85 is the first point, 121 is the second point, 199 is the third point. Okay, if I plot these points like this, I'll go over here in Excel, and sorry, if I'm going over here in the form of data points, you can see this is how a signal can be plotted dot wise. So this is the first dot, which was 85. You can see the first dot 1 comma 85, and again we are having the second dot over here. Oh, sorry, it is the sixth dot. Most of the dots are very much close to each other, so 6 comma 156. So this was the sixth dot, which is 156. Similarly, if I join all the dots, I can just show you the signal in this manner. This is the signal after joining all the dots. Okay, it is very, very simple. Now, one more thing I wanted to explain is the information given by the signal. Information. So, what is this information given by the signal? Suppose I'm saying that there is some neurodevelopment kind of issue with a person's brain, from where the signal has been generated, because of which the amplitude of the signal at 243rd point, you can see 243 point comma 2, is it 3? Yes, 2303. Or because of some kind of neurodevelopment issue in the brain, the EEG signal is having the highest amplitude over here. Okay, so it may be this increase in the amplitude might show some kind of irregular behavior in the brain. So instead of looking at the higher amplitude, what we can do is we can calculate the mean. We can calculate the mean of all the data points. Mean means we can just add up all these data points and divide it by the number of data points. So if I have to do average, what I'll be doing is over here I'm going down, just do the average of all the data points. If I do average of all the data points, what will happen? So the average is 108.85. What if this signal had contained, what if the signal had contained many higher amplitudes? After every 10 data point, if there would have been a higher amplitude, the average of the signal would have increased. Or in other words, the mean of the signal would have increased. So these words, which is mean, this mean is termed as feature of a signal. Feature is something which gives information. So if mean is more, something irregular has happened, that will come to know. Okay, so this mean is one of the feature or the information bearer for a particular signal, that you understand. There are many information bearer in the signal, or there are many features. One of the feature is mean. Another feature can be the maximum amplitude. Maximum amplitude. Okay, somewhere we have received a very higher amplitude. For example, this is highest amplitude. If the amplitude would have gone double of its size, when something wrong has happened when the signal was generated at that time. Okay, so there are many such features which give some or the other information. They are called as information bearer of the signal. Instead of showing a signal over here, what I can say is, I can say the mean of this signal is around what it was. It was, I guess it was 180. So the mean of the signal is 180 point something. Okay, if the mean is more, then the somewhere or the other there are many amplitudes which are very much higher. Okay, so let us just get back to the topic over here. Now, as the information about the signal has been given and the feature has been provided, how do we develop a model? How do we develop an equation? Because here we are not having uh, data sheet like this. We are not having data sheet like this. We had solved this problem in some of our sessions. Okay, so data sheet should be in numerical value only, in the form of input and in the form of output data. So your artificial intelligence software or your machine learning software will only identify the numeric data values, and also the output should be numeric only. Now, let us see what problems we face when we have a signal as an input instead of a numeric data. So suppose we are having, suppose we have performed experimentation on 61 patients. Okay, suppose we are having the first patient over here, for example, this baby, and this first patient, on his head we have kept how many electrodes? Say 1, 2, 3, 4. Only 4 electrodes we have kept, and those 4 electrodes will detect some kind of signal. Okay, so this is nothing but patient number 1, And in this patient number 1, FP1 electrode has generated this signal, FP2 has generated this signal, F7 and F8, so on. And later on, the doctor has detected, after a lot of intervention, he has detected that the person is having ADHD. So the person who is having ADHD is represented by 1, and the person who is not having ADHD is represented as 0. So we are having such data of 61 patients. So these signals are not copy pasted below. Okay. But the problem is, in order to feed this data in artificial intelligence software or machine learning software, we cannot feed these signals directly, or we cannot feed these images directly. Instead of feeding this signal, what we can do is we can feed a representative of this particular signal, or something which can give information about this signal. So we had already seen previously that there is something called as features like mean. If mean of a particular signal is higher, means there is something disorder which is going on. Okay, so instead of putting this complete signal, I can calculate the value of mean and I can substitute over here. For example, I can delete this and I can substitute 180 over here. Similarly, instead of writing this signal over here, I can calculate its mean and I can put it over here like if it is 192. Okay, and so on. So I'm deleting this, I'm deleting this. So this is how I can write the value of mean. Now, if I fill all these blank boxes, instead of the signal, I can put their features over here. And once I put their features, their mean values, I can write it over here, the mean values. Instead of these signal in these boxes, if I feed their feature values, I can get the numeric data, and these numeric data can be fed in the artificial intelligence or machine learning software very much easily. Okay, so these four are my inputs. So after replacing all the signals by their mean values, we can find such kind of table, and such kind of table can be easily fed as input to any machine learning algorithm, and its accuracy can be calculated very easily. Okay, so this FP1 electrode is not only generating, so this FP1 electrodes signal can have many features like mean underscore FP1 means mean of FP1, maximum amplitude of FP1, and mode of FP1. So there are, I can put three features, the value of three features of FP1, and similarly for FP2 I can put these three features values, and for F7 I can put these three features value. When I put all these values, can you see for only three electrodes how much inputs I'll be having? I'll be having 9 inputs for only three features. But actually, how many electrodes we have to fit on a patient in order to get this single row? How many electrodes we have to put? We have to put a minimum of 18 to 19 electrodes. So a one person's data, how does it look? A one person's data, when it is captured after the electrode, it looks somewhat like this. You can see it looks somewhat like this. So this is FZ electrode, CZ, PZ, C3, T3, C4, and all those things. Can you imagine if these 19 electrode signal are there of one patient, and each signal or electrode, if we are putting three features, mean, maximum amplitude, and one more was there, what was it? Mode. So 19 into 3, this many inputs we will be having. These many inputs we will be having for single patient. Okay, so currently our work is to calculate or to find. So currently our work is to find how many features are available for this EEG signal. So this current work is going on right now. Okay.